All right, today we're going to a place where our understanding of reality just breaks. We're heading right to the edge of a black hole, because it's here that our two best theories about the universe, general relativity and quantum mechanics, go to war with each other. And out of that conflict comes this incredible puzzle called the firewall paradox, a puzzle that could totally rewrite the laws of the cosmos. This right here, this is the heart of the mystery. It's like a cosmic crime scene. You have a single particle that our rulebook says must be connected to two different things at the exact same time. But quantum physics has a strict rule against that. So what happens when you have an unstoppable force meeting an immovable object? Well, some physicists think the universe's solution is just raw violence. It creates a literal wall of fire.
So what we're really looking at is a fundamental crack in our understanding of reality itself. And that crack opens up right at the event horizon of a black hole, that infamous point of no return. It's the one place in the universe where our two most successful theories seem to absolutely contradict each other. Now, that's a great question, right? If a black hole is a one-way trip, how do we have any clue what's going on at the border? Well, the key piece of evidence comes from something Stephen Hawking figured out, something that does get out: Hawking radiation. Turns out black holes aren't perfectly black. They leak a tiny bit of energy. And it's that faint whisper of particles that carries the clues to this whole paradox. To really get what's going on, you have to understand the two heavyweights of modern physics. In one corner, you've got Einstein's general relativity, our grand theory of gravity, stars, and galaxies. And in the other corner, quantum mechanics, the unbelievably precise set of rules for the tiny world of particles. The problem is, when you bring them together at a black hole, their rulebooks say completely opposite things. And here is the central conflict in a nutshell. General relativity says if you fall into a black hole, crossing the event horizon should be no big deal. It should be totally smooth, totally uneventful. But quantum mechanics has an equally strict rule. Information can never, ever be lost. And at the edge of a black hole, it seems you can't have both. One of these unbreakable laws has got to give. Let's start with Einstein's rule. It's called the Equivalence Principle, and it's a core idea in general relativity. It basically says that falling into a gravitational field should feel, well, like nothing. You're just floating. So as you cross the event horizon of a black hole, there shouldn't be any giant warning signs or crushing forces. It should be a peaceful, quiet journey across an invisible line. No drama. Okay, now for the second law, unitarity. This is a non-negotiable rule in quantum mechanics. The best way to think about it is like this. If you burn a book, the information in that book isn't truly gone. It's just been scrambled into ash and smoke and heat. In theory, if you were smart enough, you could collect every single bit of that and reconstruct the original book. The universe, according to quantum mechanics, never, ever loses the recipe. So, how do these two perfectly good laws lead to a paradox that ends in a wall of fire? Well, the main culprit is a really weird quantum phenomenon called entanglement. Einstein famously called it spooky action at a distance, and in this case, it creates a logical trap that physics can't seem to get out of. Let's just walk through this step by step. Right at the horizon, the vacuum of space is fizzing, with pairs of particles that pop into and out of existence. Every now and then, one particle falls into the black hole, and its partner escapes. That escaping particle is Hawking radiation. Now, these two particles are entangled. They're linked. But here's the kicker. For information to be saved, for unitarity to be true, that escaping particle also has to be entangled with all the other Hawking radiation that ever escaped before it. And that leads us to a brick wall, a hard rule in quantum mechanics called the monogamy of entanglement. You can think of it like this. A particle can be married to, or maximally entangled with, one other partner. It absolutely cannot be fully married to two different things at the same time. But that's exactly the impossible situation our poor escaping particle is in. This isn't just a philosophical problem. In the quantum world, those entanglement bonds are real, and they contain energy. Forcing a particle to break its original bond with its partner that fell in, well, that's not a gentle process. The universe has to resolve this contradiction, and it does so by violently severing that original connection. And the act of breaking that entanglement bond, it's explosive. It releases a tremendous amount of energy, creating a shocking, terrifying barrier right where Einstein promised a smooth, peaceful journey. And this is what they call it, the Black Hole Firewall. The proposed result is a blistering, high-energy wall of particles right at the event horizon that would instantly incinerate anything that tries to pass through it. So much for no drama.
So this idea, proposed by a group of physicists known as AMPs, is the direct physical consequence of trying to save quantum mechanics. It says that to preserve information and uphold unitarity, you have to break that entanglement bond. And when you do, all that energy has nowhere to go but into creating this firewall. The peaceful journey is replaced with instant annihilation.
Which brings us right back to our cosmic crime scene. We have this impossible situation that demands an answer. So we're left with a choice. Do we accept the firewall, which means a key part of Einstein's theory of general relativity is just wrong? Or do we have to find some flaw in quantum mechanics? Something has to give.
So how are physicists trying to solve this impossible problem? Well, the investigation is very much active, and the prime suspects are, kind of amazingly, the very laws of physics themselves. You can really break it down into three main possibilities. 1, general relativity is wrong about smooth horizons, which means firewalls are real. 2, quantum mechanics is wrong about unitarity, which means information can be permanently deleted from the universe. A terrifying thought for physicists. Or the third option, which is where a lot of people are betting, both theories are just incomplete. They're both right in their own domains, but we need a deeper theory, a theory of quantum gravity, to explain what's really going on. And then you have the even stranger ideas from the cutting edge. Some theories suggest we're asking the wrong question in the first place. What if there's no sharp event horizon at all? Ideas like fuzzballs from string theory imagine a black hole as more like a giant messy ball of cosmic yarn. Other theories propose that space-time itself gets all pixelated and granular at that scale, which could dissolve the whole problem before it even starts.
But here's the most important thing to take away from all of this. The firewall paradox isn't a failure of physics. It's an incredible gift. It's like a giant signpost at the edge of the universe, pointing to exactly where our current theories break down. And that's always where the next big breakthrough comes from.
And that's the ultimate question that keeps physicists staring at their blackboards, isn't it? The firewall paradox is this deep, cosmic riddle. And solving it won't just tell us something new about black holes, it's guaranteed to reveal something incredibly fundamental about the nature of reality itself. Thanks for joining us.